Good morning. I apologize for the delay in this video. I'm going to get videos for lessons 10, 11, and 12 posted for Algebra 1/2 today. Lesson 10 is about divisibility rules, and divisibility rules that will help you in a variety of contexts this year in math. Now, before we look at the practice problem, what I've done on my paper, just to try to illustrate something here, is in the left columns, I've just written down multiples of 3, okay, up to 102. Okay, these are all the multiples of 3. These are all the multiples of 3. Starting with 3, 3, 6, 9, 12, 15, 18, etc., all the way up to 102. Okay, and then in the column next to it, I wrote down the sum of the digits for all those numbers. So, for 3, 6, 9, there's just one digit, so there is really no sum. But starting with 12, 1 plus 2 is 3. For 15, 1 plus 5 is 6. For 18, 1 plus 8 is 9. For 21, 2 plus 1 is 3, and so on and so forth. And what I wanted to show is you'll notice a pattern with the sum for the multiples of 3, the sum of the digits, okay? Sum of digits. You'll notice that all of these sums are also multiples of 3, okay? There's a pattern that goes 3, 6, 9, 3, 6, 9, 3, 6, 9, 3, 6, 9, 12, 6, 9, 12, 6, 9, 12, 6, 9, 12, 15, 9, 12, 15, 9, 12, 15, 9, 12, 15, 18. Then at 102, it starts over at 3, okay? This is an interesting pattern that occurs in multiples of 3, that whenever you add the two digits together, you will get a multiple of 3. Okay? So if a number is divisible by 3, once again, if it's divisible by 3, you will be able to add the digits together, and that number will be divisible by 3. All right, and it works for any multiple of 3. For example, I know that the number 2,451, I know that number is divisible by 3 because I can just do 2 plus 4 plus 5 is 1. That equals 12. Okay, since 12 is divisible by 3, then the whole thing's divisible by 3. Okay, and I could, if I just said, okay, tell me if 2,451 is divisible by 3, you could always check it by doing long division, right? You'd see, okay, yes, it is, if it's an evenly 817 times. But the point is, you can do that without doing long division, just add the digits together. All right, so that is a good rule to use, a good rule to know, because let's just one quick example of a time you might want to know that. If you're doing, let's say, 51 over 84 as a fraction, and you're trying to figure out if that can be simplified, and you're having a tough time figuring out numbers that fit into 51 and 84, you can think, well, let's try 3. 5 plus 1 is 6. 8 plus 4 is 12. Those must both be multiples of 3, so you can divide, you can reduce it. Okay? You can divide both the numerator and denominator by 3. Okay, you'll have to probably do some log division then to get your reduced fraction, but 51 over 84 can be reduced to 17 over 28 because they're both divisible by 3. And I can just tell that by inspection because the sum of the digits adds up to 3. Okay, now on page 39 of your textbook, at the bottom of it, you have the rules for divisibility. I'd like you to copy that into your notebook, okay? Because these are the 4 rules of divisibility you should know this year. 2, 5, and 10 should be review, all right? That's pretty easy to tell if a number is divisible by 2, 5, or 10. If it's even, or if the last digit is 0, 2, 4, 6, or 8, it's divisible by 2. If it ends in a 5 or a 0, it's divisible by 5. If it ends in a 0, it's divisible by 10. But the rule for 3s here, that's probably one that you might not be familiar with. Okay, and again, a whole number is divisible by 3 if the sum of its digits is divisible by 3. Okay, so you can pause this, copy that into your notebook just so you have it available to you. And then after you've done that, we look at the practice problem here. And the practice problem is a little bit different. It's giving you a whole bunch of numbers and asking if they're divisible by 3, 5, or 10. Okay, so let's take a look at that. I'm going to how you write your answer for this might vary a little bit. I'm just going to go through by each number and write what it's divisible by. Okay, let's actually start with 10 because that's the easiest one. I'm looking for numbers that end in a 0, numbers whose last digit is a 0. Well, the only one that applies to is this one, okay, 72,840. That's going to be divisible by 10. 5. Well, it looks like they're actually all divisible by 5 except 1, because these first 3 numbers all end in, except for 2. This number does not end in a 5. All 4 of these numbers are divisible by 5, because this one ends in a 5, this one ends in a 5, this one ends in a 5, this one ends in a 0. Now, as far as 3 goes, I'm not expecting you to do long division to see if these numbers are divisible by 3. You just have to add the digits up. 4 plus 7 is 11, plus 2 is 13, plus 8 is 21, plus 5 is 26. I'm just going to write that number here, okay? Just so I don't have to, hold it in my head. 3 does not fit into 26, so it does not fit into that number. All right, all I have to do is find the sum of the digits. This problem, 4 plus 5, 9, 11, 19, 24. Yes, 3 is going to be a factor of this number because the sum of the digits is a multiple of 3. 3, 8, 17, 23, 24. Yes, 3 is also going to fit into this number. 2, 3, 5, that's 10, 17, 19, 24. Yes, 24 is still a multiple of 3. So 3 fits into all of these numbers because the sum of the digits is 24. This number, 8, 4, 6, 3, 12, 18, and it's 21. Yes, it fits into that number as well. And then 7, 2, that's 9. 17, 21, got 21 again. Yes, 3 fits into that number as well. So 3 actually fits into all of these numbers except for the first one, because the sum of the digits for these 3 numbers is 24. The sum of the digits for these 2 numbers is 21. 24 and 21 are both multiples of 3, so 3 fits into the whole thing there. Okay, so divisibility rules, lesson 10, good rules to know, helps us in a variety of contexts. All right, I'll see you back for lesson 11.